1.73205. Oh, sorry, am I going too fast?
05.
0808.
0 what?
08 again.
It doesn't repeat, I'll tell you that. So it doesn't start repeating there. I do know that, so I'll put an 8 there, but it's probably a 7 something. Because they are exactly like pi. They never stop and they never repeat. Square roots of numbers that aren't perfectly square never stop and they never repeat. Okay? So that's something that are also in real numbers. Okay? So we have what's called the set of real numbers. It includes these types of numbers. So these are the members of the set. There are subsets here because there are ones that stop. Okay, those are a subset of the real numbers. The repeating ones are a subset of the real numbers. And the ones that never repeat, go on forever, are a subset. They are part of the real numbers, but we can classify them separately because of those three things. Okay, so this is just representing some of your different types of numbers. Now, there's some properties that go with these real numbers. They're kind of silly. Properties. Properties, yes, that's right. Okay. With a real number, if I take any number and add 0, so any number and add, any number, and I add 0, what will I get?
That number.
That number. Same number.
It's like timing something by 1.
It is. This is called the additive identity. In other words, when I add it, I get itself back. Its identity comes back when I add 0 to it. It gives me the same thing. Okay? That's kind of nonsensical. But what it does allow us to do is to define opposites. So when you were a little kid, you started out with what we call the counting numbers, okay, or the whole numbers. When you were a little kid, you started out with the numbers like this. Right? You didn't work with fractions, you didn't work with decimals, you didn't work with negatives. Life was easy. We added these numbers, we subtracted these numbers, we multiplied these numbers, we divided these numbers. Life was easy, okay, because you only had those numbers to deal with. Those are called the whole numbers, okay? But then they said, oh, wait a minute. What is the opposite of a whole number? So they made what are called opposite numbers. Well, all we do is we put a negative in front. But how do we know they're opposite? Because when I add the whole number to its opposite, I get 0. That's how we define an opposite number. If you add, so if I take a whole number and add its opposite, it gets to be 0. So an example is 2 plus negative 2 is 0. That's how we define an opposite, because the whole number plus the opposite will bring me back to 0. Okay, so that's how they defined it. We put all these numbers in one group, the whole numbers and the opposite numbers, and we called it the integers. Integers are whole numbers and their opposites. I have a question. What's the opposite of 0?
Nothing.
Infinity? 0.
It's just 0. There is no opposite of 0 because 0 plus -0 doesn't make any sense, okay?
What's
So there's no opposite of 0. 0 is neither positive nor negative. It's 0. It's not positive. It's not negative.
for the guy that invented 0? Thanks for nothing.
Yeah, thanks for nothing. That's right. Okay, so basically now we have integers. So we now have positive and negative ones. So in part of our group of real numbers, we have what are called the integers. Now we didn't list them up here, but you can make any of these opposites. So you can find them in there. So it's whole numbers and their opposites. Okay, so that's really what we're talking about when we're talking about opposites. We're getting into positive and negative numbers. We work with positive and negative numbers. Can anybody think of a situation where we have negative numbers? Yes.
Temperature.
Temperature, yes, we have negative, below freezing. I like the metric method because freezing is at 0, -1 is -1. It's colder, okay? Here we go to 32, which is freezing, and then we say 2 degrees below freezing, which is really 30, okay? So it makes it a little harder, okay? Another place where we use negatives, yes?
Below sea level.
Below sea level and above sea level, okay? The altitude, that's called altitude. When it's below sea level or above sea level, that's how high a mountain goes. It's measured in how high it is above sea level. Okay, so that is what we're looking at there. My husband loves this joke. So when he goes, he's gone on several cruises to Alaska. And what he hears quite often when they get off the boat is he hears passengers ask the people on the ship or the people that are helping them, what altitude are we at right now? What altitude would they be at?
0.
Basically 0. They're right at sea level. But why do they think it might be higher than that?
Because
Maybe waves and something like that.
Because what?
Waves.
Well, waves could be. I doubt that. Not because they're dumb.
they go from
Temperature?
Europe to
Temperature is a good one. Temperature, because if you're up in Alaska, it's going to be colder. And we usually associate coldness with being up higher. Although right now, that's not true. The mountains are warmer than it is down near sea level right now. In our area, that's true. Okay, but that's why they think that. Or I think it's because they think they're up north, and north has to be higher, doesn't it? Because on a map, north is always up. So it's got to be up. So I think they think
because
that.
of gravity, like you're the one up there, but then
Yes.
FaceTime they're up, so you're
Yeah.
upside down.
Yeah, so there's a lot of different reasons there. Okay, that's basically the whole things in 4.1 and 4.2. So I'm going to give you some problems to look at for this. I have to find out where they're at.